Good morning students. Today's topic is surface and interfacial phenomena. This is covered in unit 3 of your syllabus. Now, first of all we will discuss interface. What is interface? Interface, the boundary between two faces which exist together is known as interface. Means interface is the boundary between the two faces. It may be liquid-liquid interface or solid-solid interface or liquid-gas interface. Okay. In some cases it's gas-gas. In gas-gas no interface is possible. Okay, so interface is a boundary between the two different faces. Next is surface tension. Surface tension is defined as tensile force acting at the surface of liquid which is in contact with gas, or it may be between two immiscible liquids. Its unit is N/m. Okay, means surface tension is a force, tensile force which act on the surface of the liquid which is in contact with the gas, or it may be between the two immiscible liquids. Okay, in liquid state cohesive forces and adhesive forces exist. Okay, the forces acting between the molecules of the same phase are called as cohesive forces. Cohesive forces means the forces which exist between the same phases, molecules of the same phases. And adhesive forces means the forces which exist between the molecules of the different phases. So these are the two forces, that is cohesive forces and adhesive forces. The molecules in the bulk liquid are surrounded in, as you can see in this figure, the molecules in the bulk liquid, it is surrounded in all direction by the other molecules. The net force acting on this molecule is 0. Okay, the molecule which is in between the liquid. Okay, the net force acting on this molecule is 0, but the molecules on the surface of the liquid experienced an inward force. The molecule which you can see now, the molecule which is on the surface, it experiences an inward force. Force means inward force towards the bulk. This force pulls the molecule of the interface together and stretch the surface. It means some tensile force is acting on the surface which is called as surface tension. Okay, you can see in the diagram the molecule which is in between the liquid, no force exists. Okay, and the molecule which is on the surface, the inward force exists. Okay, this is a tensile force which act on the surface. It is called as surface tension. Now interfacial tension, it is a force per unit area length that exists at the interface between the two immiscible liquid phases. Interface I have already told you na, interface is a boundary between the two phases, different phases. So interfacial tension is a force per unit length that exists as the interface between the two immiscible liquid phases. If two liquids are completely miscible, means they are completely miscible, then no interfacial tension exists. But if these are immiscible, then the interfacial tension exists. The interfacial tension are less than surface tension because the adhesive force between two liquid phases which form an interface are greater when the liquid and gas phase exist together. Okay, means the interfacial tension is more when the two phases are liquids, but when the two phases are liquid and gas, then an interface are greater. Okay, suppose a soap film is stretched by applying a force F. A soap film is there, okay? This film is stretched by applying the force F to a movable bar of length L. The surface tension gamma of the solution forming the film is a function of the force that must be applied to break the film over the length of the movable bar in contact with the film. So interfacial tension gamma is equal to Fb upon 2L, where Fb is force required to break the film and L is the length of the movable bar. So this is a formula of the interfacial tension. Next is surface free energy. The molecule near the surface of liquid have more potential energy as compared to the molecules in the bulk. Okay, this means that as surface of the liquid increases, the more molecules have this excessive potential energy. This energy is proportional to the size of free surface and it is called as surface free energy. Means surface free energy means it is the energy which is proportional to the size of the free space surface. Okay, means the molecules on the surface of the liquid, they experience the energy, okay, as compared to the molecules which are in between the bulk of the liquid. So the energy is proportional to the size of the free space, and it is called as surface free energy. For example, liquid droplets assume a spherical shape because the sphere has the smallest surface area per unit volume. To increase the surface of the liquid, the work must be done against the surface tension. Okay, when the bar is at position and mass is added to extend the surface by a distance ds, the work done is represented by the equation dw is equal to F into ds, where dw is the work done. Okay, you can say this is a formula. F is the force, ds is the distance. As we know that gamma is equal to Fb upon 2L. So dw is equal to gamma into 2L into ds. As 2L into ds is equal to increase in surface area dA, okay, produced by extended foam film. So we can represent 2L into ds with gamma sign. dw is equal to gamma into dA. For finite changes, W is equal to gamma into delta A, where W is the work done or surface free energy increase expressed in ergs. Gamma is the surface tension, okay, its units are dynes per centimeter, and delta A is the increase in area in centimeter square. Surface tension is defined as surface free energy change per unit area. That's all for today. Thank you.